Okay, so today we are going to write a doubly linked list in Rust. We're first going to read the article we wrote last time. And by we, I mean me. We just use collective pronouns here for the hell of it. Okay. And then we will write that code. So let's get started. Did you know there are infinities that are larger than some infinities? Okay. Okay, Amit. We'll go with that. In the last article, we talked about what a linked list is and how to implement a singly linked list in Rust. We found out that it wasn't that bad and simply accomplished by using a box, a type of smart pointer in Rust. However, doubly linked lists are a different story. Needing to manage multiple references and support mutation of the underlying data is not the easiest thing to do for beginners to Rust. What is a doubly linked list? Let's find out. In a singly linked list, we store a reference to our head node, and each node stores a reference to the next node. A doubly linked list simply adds two more pointers, one for the tail of the list and one in each node referencing the previous node. So this example has ABC with links back and forth. We can construct a doubly linked list in Rust-like pseudocode as follows. We're not going to read that code, but I'll leave it up there for you to read. That pseudocode. Obviously, this code doesn't work, but it should demonstrate what the ultimate result of constructing a doubly linked list would look like. Each node has a value, a prev, and a next. The list has a head and a tail. There are several optimizations now available to us versus the singly linked list. First, we now have O1 access to both head and tail for fetch, insert, and delete. Inserting at the end of the list is very simple. We can also optimize traversal by starting at head or tail or both. Let's go. Appending lists, aka concat, is also O of 1. These operations conceptually are all very simple. Managing multiple references. All of the pseudocode is great, but it's not valid Rust. We'd have lifetime issues, borrowing issues, and wouldn't be able to mutate anything. What we need is the ability to manage multiple references and to mutate the underlying data in a safe way. Rust provides two ways of doing this in the stdlib. arcmutext, which is thread safe, rcrefcell, which is not thread safe. Both arc and rc are reference counting pointers. Essentially, they keep track of how many references have been created to ensure that the underlying data is not dropped until all references have been. But arc and rc don't allow for mutation of the underlying data by themselves. Disallowing mutating of shared references is one of the points of using Rust in general. That's why they must be used with a type of shared mutable container. In this case, mutex, which is thread safe, or refcell, which is not thread safe. The downside of using arc is the increased overhead of ensuring atomic operations. I recommend the books section on RC for further understanding. Here's the implementation of a doubly linked list in Rust with pop front, push front, pop back, push back, and append methods. I chose to use arcmutex, but the implementation with rcrefcell is nearly identical. I think the only thing I want to point out, maybe after here, one point worth noting is the use of clone on arc or rc simply increments the count. It does not, rather than cloning the underlying data. Okay. Let's make this a dot clone. Obviously, we have to do a little select here. And we'll let you read the summary on your own, as usual. Live edits to the article. Okay. I think this is good. And let's write that code for the doubly linked list. Let's see. Let's check in with chat real quick. After fixing so many design flaws in my compiler, I'm on symbol resolution. By that I mean search of symbol in the scope namespace, etc. Cool. Did you know that W is one more than infinity? Oh, that's really funny. Also, 0, 1 in my name stands for all fractions between 0 and 1. Totally not because infinite coder was already taken. Hilarious. 166p says a lot about my internet. Ooh, what does that even mean? I'm so scared. My compiler is full of arc mutex. Yeah, not surprising. Yeah, you guys can nerd out about numbers. Have fun with that. Okay, so let's get started. Let's get to our Rust DSA TMUX session. This looks good. We have a clean. We don't have a clean one. Oh no! What did I do? What did I do? This was like, I don't know what this is about. I guess it was just a few little changes. Okay. Linked list. IDK. What I changed. Okay. Very professional and very good. So let's touch our doubly. We're gonna be really impressive and call it a doubly linked list for our mod name. And then we're just gonna go in here to our lib to begin with. Let Rust Analyzer do its thing. And we'll go to doubly. Okay. So before we get started, let's just do this because it's going to be easier. It might be interesting actually. I'm not going to copy all of this code, but let's copy our basic types because I think there is a nice there's a nice example here of the difference between singly and doubly that I think is worth illustrating. So if we just start with our basic struct types that we used for our singly linked list. Now we're going to have to give this, we don't have to give it a different name, but we're going to. We'll just call it a doubly linked list. I can't see chat. Hold on a second. Did I know that 3 is more than 2? I actually knew that. That is something that I knew about numbers. I mean, it's 1 more than 2. Yeah, that's good. That's very good. Arc mutexes is why you shifted to C++ for compiler. That's hilarious. It's not W, it's omega. I knew it wasn't a literal W, but I never remember what all the Greek letters are. So it looked like a W. Okay. I have no idea about static site generators. I've never really played with them very much myself. I mean, I know what they are, but, you know, that's about it. Okay, so let's get started. So we changed our name. We're just going to leave struct node T the way that it is. I think we're going to go ahead and alias this time. Last time I didn't. Wow, what did I just do? I hit all sorts of buttons. Okay, let's try that again. This should be just type. What do we want to call it? Let's just call it a link type link T, and we're going to choose arc mutex this time. I'm going to have to do some imports, but I believe that I can just do this, and let's just put our option in the link. Okay, so we've added our prev, we've added our next, and then here we have our last and we have our head, right? So we could call this first and last. Head and last kind of feels weird, but unlike a lot of times, and I think I even did this last time I did a doubly linked list in Rust, is a lot of people will call this last element the tail, and that's actually not correct, right? Technically, the tail for a list is all of the elements after the head. So you have your head and your tail, right? So if we had a more like typical functional type linked list, you'd have H and you'd have T. And T would actually be, it would have its own H. Like you could keep going down recursively. So let's say this was OCaml, it might look something more like this. Let's see. I think we do it like this. I can't remember right now. Oh no, I had another layer on my keyboard. So then we'd have H1 T, you get the point. It's recursively going down. This is the head of the next list, the tail that was before. So yeah, very exciting. Let's see. So let's go ahead and get some of these imports out of the way. I believe these are all in sync. How does this work? Do we do it like this? Arc mutex, maybe. Looks good. Type link T. So what do you not like about my link T's? Binary operation cannot be applied to link. That's fine. We probably don't need it to be. That was mostly for tests in the last one. We'll just deal with that later. Okay, so Rust likes our types finally. I'll never stop calling it the cooter. And you can't make me. I don't want you to. Did you see my did you see my tweet about that, F collector? Implementing a con style list in Rust, which of course Lispers weren't like totally thrilled that I was saying cons as a list, but that's okay. All right. So let's start with a little impl node T. A meat slacking. Yeah, seriously. What's up, Nightshade? Let's see. So we have our impl node T, and we're gonna have our function new. We shouldn't need this to be public, but it does return something, doesn't it? It returns a self. And this is going to be pretty simple. I guess we do need a val, don't we? Otherwise, what are we doing? All right. So let's see. When we first create on our new, we're probably not going to actually have anything else. So let's just do this. And we will say classic me. We will say value. We will say prev none. We will say next none. Okay. That's our node new, and then we're going to impl our doubly linked list. I hate how much that is to type, but at least I'm fast at typing words, not always on the code as much. And I don't think this is going to take any arguments. We're just going to do a self, and it's going to just start with an empty list, which is going to be doubly linked list. Len 0, head none, last none. This is fine, Copium. So true. What's up, Purplish? Oh, I always forget that. I always forget in the impl block I have to actually bring my generic parameters here. Impl T. I think that's my mistake, right? Look at that. Look at that. I know things. Do people like do they like little... Really? It's FMT. Okay. Sorry about that. Do they like little spaces here? No. Guess not. I guess this is fine. Oh, it made changes to my linked list, but not my doubly linked list. Nice. Yeah, it's going pretty well. I mean, it is fine. It's not Copium Nightshade if you want to have memory safety, okay? If you want thread safety and memory safety, it's fine. It's your goal. Well, you're very good at your goals of slacking. Okay, so we have our linked list. We have our doubly linked list. Yeah, who needs safety? I was thinking about like my terrible test that Nightshade was giving me a hard time about, and how if I shared this repo with like a potential employer that they might look at my tests and kind of scare. Amit. No, you're joking. Little over the line. All right. And yeah, like a potential employer scared. Yeah, that's fine. Yeah, a potential employer scared or scarred by the way that I write my tests in this repo. All right. Function new, self, doubly linked list, len head last. The head last is really bothering me. I guess we're just gonna call it first, even though I kinda hate it. I guess we're gonna keep with head. Like, you just want to call it a head and a tail. You don't want to call it a head and a last. It just bothers you. Okay, it bothers me at least. Okay, so let's just start with constructing our list. And we'll just say let mute L. Yeah, real coders code in assembly without any safety. That's true. Doubly linked list, use size, new. And why am I over here? Oh, it's because I forgot. It's actually a me problem. Isn't that surprising? Nobody thought that was a me problem, right? You guys were all like, no, it's not your fault. Let's see, l.len 0. This is where I will this probably won't work. I don't exactly remember how this part works with the whole arc thing, but we'll just say l.head is none and l.tail is none. Nice. Okay, we should get partial eq errors. You don't do this right. Okay. So let's try to figure this out. So let's just start here. Oh, I'm being dumb anyway. The link type is wrong anyway. It's not an option arc mutex T. I knew this was too simple. Yeah. How about that for a beautiful type? That is a beautiful type, is it not? It's so good. Okay. Okay, so I'm guessing we're still having a problem here. Let's see what the full output is. Where mutex doubly linked list, node T, partial eq. Wait, this error originates. Okay. Consider introducing a where clause. Where mutex. What the hell is that noise? Guess it's the washing machine. It's just really bothering me for some reason. Doubly linked list, node T, partial eq. So it's just trying to say that has to be partial eq. Oh, well, I didn't finish. Duh. Okay. That was silly of me. Now we should actually have more. It's still saying the same thing. So I don't actually remember how this part works. Can I not partial eq a mutex? Let's look that up. Where T partial eq. I think this could be the right thing, but I don't understand. I don't understand why that's being the way that it is. Let's just try that. Now they want me to do this whole thing. I just want to say like where T partial eq. But maybe that's not the right way to go about it. And at the end of the day, if I just have to like go through this more annoyingly, then I will. Cannot compare T with T. No implementation for T equals T. Where T partial eq. Sure. I guess we can just keep. Let's just try putting it here too, and see what happens. Does this make you happy? No, you're still mad. You're still so mad at me. It's very sad. No implementation for T equals T. Sure. Sure. It still wants me to do this whole mutex node T partial eq. We could try it, I guess. I don't remember having to do this last time. But maybe I didn't do any eek tests like this. It's a little bit. Oh, I just thought of a way I can get around this. Okay. Let's get out of all this partial eek business. And we'll just work with the types directly. How about that? How about that? So instead of all of this, we should be back to a nice state. And instead of assert eek, we're just going to go with the regular assert. And we're going to just say l.head is none because it's an optional. So then we don't have to do this weird eek stuff. We can just go here and we'll just deal with not messing with the whole eek thing. I said l.tail. I like literally can't help myself. Okay. l.last. And we'll just run a test real quick. Looks good. Okay. We're so good at this. You could do t partial eek. Yeah, but that's exactly what I did before. Like the where t partial eek means the same thing. It's just, you know, like a different place, but it didn't fix the actual issue. So that's the problem. The problem is actually the mutex not having partial eek. It's not really the t not having partial eek. And it's just easier if we just kind of sidestep all of it for now. At least for me. Okay, so we created our doubly linked list. We have it new. We're so happy. So let's do a little push front. Our push front is going to have a value t. And what are we going to return on a push front? Probably unit. We're probably going to return nothing. You were yeah, but it means the same thing. Like it's syntactically the identical, is it not? Or semantically identical. I don't think it's going to fix it. And I don't want to spend time on that. I'd rather just get the logic right. Okay, so our very first thing. Our very first thing is push front, right? So if we're inserting our very first node, it means that head is none and last is none. All right, I think I have to change head to first. It's too annoying. I can't think through it. And head first. G. Okay. It's gonna be okay, guys. We're gonna get through this together. Okay. So let's just start with if head is none. Or we could do a little if let some in some head equals. Oh no, because then I will actually probably want to take it. Do I want to take it? Maybe. We'll start with this. It's fine. If let some head equals. I forgot to put an and self. And mute self. Self. I said head. It's supposed to be first. This is going so well. Equals self.first. Okay, so now we have an arc mutex node T. We're so happy about it. And we're going to see what we can do with it. So if there's a first, we want to, out of here, we can actually just create our new node. And we can say let n equals node new value. Okay. And then tempting to do like a new link or something like that. If there is a head, there's also like a part if this is the second element that we have to update tail as well. So that's when I start wanting to like actually deal with that part. We'll just put this in here. We'll just say if self.len equals 1, we have to update tail. So that should be afterwards. That should be fine. Let's see. So this is the new head. So we are probably going to want to just say, well, maybe we can actually do this up here. Let's see if this works. Arc new, mutex new node. Okay. There's our arc mutex node T. And our first thing we're going to do is say, we've already taken the head out, so we can actually just say self.first equals sum in. And that should be fine. I guess we want to do in.clone because we want to use n at the last. Self.first in.clone first.prev equals sum in.clone. And maybe what we actually want is this, and we're just going to say if self.len equals 1, then first dot, is that right? Do I need to update the tail? No, I don't have to update the tail no matter what, right? I'm sorry, the last. That's prev. We just have to point the next to this first. That's all that it is. So that's kind of why I want a clone, actually. So we're actually going to do not a clone there. Okay, right. That's my arc mutex. I'm thinking through this. Yeah, I mean, you can. What plugin do I use for type inlay hence? This is just, well, first of all, this is Emacs with Evil Mode. This is Eaglot, which is the main LSP, one of the main LSP plugins for Emacs. And that's what provides these hints through Rust Analyzer, of course. I don't know if I missed any other chats. Okay, anyway, I got a little distracted. Right. So the point is, let's maybe just write out what we need to do real quick. So, no, I don't need to do that. I think I'm just getting ahead of myself. And I'm starting to feel like this is taking too long. But it's fine. It's fine. This isn't that hard. So we have first, right? We have our existing first, which is the first here. That's already in arc mutex. We're totally happy about this. We don't have to worry about it too much. It's not that big of a deal. The first thing that we do is we say self.first is now our new node. We already have first in the old first, right? We already have that. So this is fine. How about this? We'll call this old first. Old first. First is such a weird word. Isn't first a weird word? Okay, I promise I'm not high right now. Self.first equals sum in.clone. Okay. Then we go with old first dot prev equals sum in. we're good with that. The next thing we have to do is say, yeah, we just have to set the next, right? So we're going to have to do like the whole arc mutex thing. And I think this is the part that I'm not used to yet, is that we have like some of these errors and stuff like that in here. This is the part that I'm not completely used to, because I've never really messed with the arcs all that much. Okay, so I have to figure that out. I don't actually want borrow mute. One option is, before actually creating the arc mutex, I could do all the mutation and then create the arc mutex inside of this, and it could make some of that nicer. That's one idea. So instead of the way I did it here, I could just say let in is this. I think this is what I want to do. That way I don't have to deal with results or anything here. I don't have to mutate it after I've put it in the arc. I think that is going to be annoying. So what we want to do, let link, and we're going to say n.next equals sum old first old first dot clone. Okay, that's better. Then we have our link, and then here becomes a link.clone. This just becomes link. And if this is the tail, is there anything special that I need to do? Like, if this is the second element, I don't think there's actually anything special. At first I was thinking there is, but there's not. It's just going to be for delete and stuff like that. That will have to do that. So here we have an arc new, we have a link.clone, we have a sum link. I think all of this is good. What's up, Hans? My hairline is not receding, okay? Like, literally, this has been my hairline for 20 years. Sometimes it gets a little bit thinner up there, but it's not so bad. I know you're just memeing though. At least you better be. Meta, I promise, me pressing next to doubt. Nice. Yeah, skill issue. All right, so we have this. Let's do our else. So I was wrong here in that this is fine to just take. It's fine to just take ownership of. Since it's an arc mutex, you technically don't have to do that part, and it will just kind of like figure the rest of it out. But it's fine to do this. The only thing is I am gonna have to do a lock here in order to actually do it. So I think what I'm gonna want is like a function to do that for me, because I'm gonna have to do that so many times that maybe I want a function to do that for me instead of me having to implement the same effing logic over and over and over again. Probably the right choice, because this is going to end up being a result, and it's just going to be a result unit, and then whatever error I end up getting from that. So that's probably our next path here. Okay, so if this is the very first one, then in that case, we can just go down here And yeah, we have a little bit of duplicated logic right now, but that's fine. And this just becomes self.first equals link. Link.clone. And self.last equals link. And then finally at the end, we have to say self.len plus equals 1. Only language is Holy C, and the only OS is Temple OS. Yeah. Please don't get problematic on the stream, guys. Thanks. Okay. So why do you hate me here? Why do you hate my clone and my link? Oh, it's because I forgot the sums. That's all. We just have to add some sums, and then we're happy. It's nice just like thinking through why some things are read squiggly instead of just going right to like the actual error. Okay, so then the only error we have, which we're going to have to do for a lot of things anyway, is this whole old first.prev. So I forget how this works, so we're going to look at the arc docs real quick. And it's not the arc docs that actually matter, it's the arc. It's the mutex docs. Mutex, spelled it wrong. Yay for fuzzy search. Yeah, I'm not gonna do pointers and unsafe code to do what I can do without pointers and unsafe code. I mean, I'm still using a pointer. We're using smart pointers, all right? Well, Ons, I will say that that is a self-awareness that a lot of people don't seem to have. So I appreciate that. The data can only be accessed through the RAI guards returned from lock and try-lock, which guarantees that the data is only ever accessed when the mutex is locked. Okay. I don't really know if I want like which one I actually care about, but we'll just go with the whole lock one, I think. C mutex.lock.unwrap equals 10. Okay. Yeah, I think this is good. Are you actually asking me, or are you like memeing? If they are smart pointers, why use they need arc and mutex? Why not just box? Because it's a reference counting smart pointer. Who knows? You don't even know at this point. You don't even know if you're memeing or not. All right. Let's do this. I am kind of interested in implementing this as a function, but let's just start and let's not factor it out too early. So if we say old first lock, okay, and then what do we have on lock? That's what I'm wondering. Okay, so I could just map it. That doesn't sound terrible. Old first.lock map. And then what do I have in this map right here? I have a mutex guard and a node T. Now, how do I use that mutex guard? For now, let's just delete that. Let's pretend we're going this way. We're probably going to want some new lines here so we can actually read this. And then let's see what we have on in. Okay, now I can just, this is what I was hoping. I was hoping that I would kind of just be able to use this in, unless it's fooling with me. Yeah, I can just use the n as I want. Okay, so the only thing I need to do then is say mute, and then the whole point of this was to set n.prev equals link, right? Yeah. I think this was the whole point, is to have n.prev equals link. Expected option arc mutex node t global found arc mutex node t. Okay, very exciting. That's because we need, it's just the type error. Some link. Okay. This is fine. Old first dot lock dot map. Okay. So let's see what our actual error is now. Value used here after move. Did I use it after move? When did I use value after move? Oh, dumb. This is just because this is wrong. Okay. So this is just n. And we also need to mark it as mute. That's n. Okay. We're getting very close. Let's see what this error is. It's probably that it returns a result. Yeah, it's an unhandled error. That's fine. Unused result that must be used. Okay, so what we're probably going to do, I'm trying to remember what the actual type is here. Lock result, mutex guard. Doesn't it just return poisoned error or something like that? I can't remember right now. I mean, I guess it's a lock result. Okay, let's just do this. Then we'll know what the actual type is, thanks to type inference. Poison error, let's go. Okay, so I could, like in normal code, I would probably start doing something like, why did it go away? It's so annoying. We're just going to say unit. See, it's there, and then it's going to go away when I do this, huh? No, it didn't. It didn't this time. Let's just say poison error. Can I just underscore this and just say I don't actually care where that comes from? And then I guess I don't need that, since that's what I'm actually returning. Yeah, how did this get here? What did I do? Okay. It's fine. Because unwrap is then going to cause an exception. So then I'm raising an exception instead of using the result. That's not allowed in type signatures. Okay, fine. Be that way. Poison error, mutex guard, da 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 da. Use the operator to extract the result. So I can just do that. Oh, okay. It's telling me what to do. It's telling me what to do there at least. And then, okay, can I just, what do I need to do then? Can I just do this? Not found in this scope. That's probably true. Now you're actually telling me something that's true. All right, where is poison error found? That's what I want to know. Stood sync. Okay. So is it poison or poisoned? It's just poison. All right. We're getting somewhere. It is better to make your own error type, yeah. If this code doesn't execute, isn't it harder to find an error? I guess I don't know what you mean. Hey, what's up, Alice? All right, voice ban, huh? All right, we can try this. We can try this. We'll see. I might disable voice bans during this series because they kind of fuck up everything. Let's see. Yeah, I'm not going to do the voice ban. I'm too annoyed. This feels like you're exposing implementation details, which locks you into stdlib mutex for. Oh, it absolutely is. I'm not saying this is a great interface. I should just return my own error. But if I was to like unwrap, I'd have that same problem, which I know you weren't the one that said to unwrap. I'm just trying to get it to work. I mean, without having to go through all of the annoyance. I could just use like what is it, anyhow, but I'm not used to using anyhow, so I'd rather just create this actual error. Let's see. I guess we should just take the actual thing, even if it's really annoying. It's not poison error T, though. I guess we're just going to take literally this whole stupid error. Wrong place. Okay. So this, obviously I don't have to be namespace because we're in this namespace. And that looks fine. We just need mutex guard, which I'm gonna guess is on sync as well. Mutex guard. Like if it unwraps, it's easy to find an error, but if it silently doesn't execute, good luck figuring out why the list is empty. I guess I don't know why it would silently not execute. Like a result doesn't hide the error. A result simply gives you an error as a value. What do you mean? You expected result and you found unit? Where? Oh, yeah. Well, at the end, obviously. Obviously that's true. Yeah, I guess this isn't going to work in one. No, I can just do an OK unit at the end. That should work. Okay, so now we have an OK unit. It still hates me. Oh, it's so annoying. Ref cells were so much easier than this. Old first is borrowed here. Returns a value referencing data owned by the current function. Okay, can I just throw in a little clone? No, it still doesn't matter because it's still borrowed. Because the mutex guard is there. Thank you. I don't know. I think I might actually go to unwrap after dealing with this extreme annoyance. This is really annoying. This is really, really annoying. Okay. So let's just see what doing unwrap feels like. Like maybe that's not what you meant, Infinite, but it sounds like you're saying like results are hiding your errors. And that's not true. Okay. Way fucking simpler. Okay, it's compiling. That's all I care about. So right. We went to unwrap. We're doing exceptions, and that's just the way that it is because we only have so much time, right? Results are annoying. That's why you like effect systems. I actually like results personally, but I get it. I get it. I think cargo format just takes those away for me, if I remember right. No, I thought it did. Maybe I'm thinking of something else. Okay. We'll just do this. And I don't need borrow mute. And cargo format. There we go. That's what I was thinking of. It removes the braces for me. It just did it. That was it. Okay. This looks fine. Let's just do a cargo test, even though we didn't change anything, just to see what happens. Doubly linked list. Doubly linked list. Okay. Even though I don't know what it's off about right here. What do you think? What do you think is happening? Okay, so let's go ahead and push a value. We're going to push front a little 5. And because we don't have pop, we don't have like a really nice way of testing this yet. Because I don't want to deal with unwrapping shit in my tests. So we'll just leave it at that for now. And now we'll implement pop front. Okay, pop front takes a mute self, and it's going to return a T that it owns. If let sum first equals self.first.take, then we have this. And we have to like deconstruct this whole arc. This part could pose some challenges, but once we figure out push front and pop front, the rest of this should be pretty easy. That's, you know, famous last words, right? Okay. If let sum first, self.first.take, right. So the main thing is that, yeah, I think we just want to like probably create that whole lock and get everything out of it, right? So, how do we want to do that? How do we want to dereference it? I guess let's just think. what is still referencing this thing? Yeah, I guess it would be first dot next. First dot next dot take. We might want to do that. That's just going to replace first dot next with none. And we'll just call this new first. And then this isn't going to work exactly that way. Let me think. Because that requires mutability. Yeah. Smart pointers are annoying, aren't they? Let's see. How can I dereference all the pointers here? I already dereferenced one. The other one is going to be in prev, and the other one is going to be potentially in last. So I'm trying to think like how all of that works. I guess what I actually want to do is just replace what's in all those different references with something else. Yeah, I'm not sure what I want to do here. Stream to the stream. Thanks for the follow. Well, I don't think I'm going to be that surprised if I don't finish a doubly linked list in one stream. It will be sad, but I'm not going to be that surprised. Okay. Let's just think about this for a little bit. Let's just look at a couple of these things. Arc.clone and lock. Sure. Examples. Arc no, mutex new. Arc.clone and data, tx.clone. We unwrap the return value to assert that we are not expecting threads to ever fail while holding the lock. Sure. This is fine. The lock is unlocked here when data goes out of scope. Okay. So I guess all I want to do then is say let mute old first equals first dot lock dot unwrap, and that gives me my mutex guard. And then the next thing that I want to do is then use old first here. And now things are actually working. So that means we're most likely on the right track. And once we have the new first, we should be able to say self.first equals new first. We don't actually have to do anything special because we just like took over that exact option and reference. And we're not going to need it in the future, so that should be fine. So this is all good so far. We have to do a self.len minus equals 1 before we forget. We updated our length. What else do we need to do? We did our prev. Oh yeah, prev equals none on the new first. That's important. So this is where we end up doing more annoying things as well, just to set prev to none. So that's kind of annoying. But we can do that. It's fine. So we already know that this is... Do we know that new first actually has a thing? We don't really. So we're going to have to do a little if let sum new we'll just say first node. These names are terrible, but that's okay. So this actually can just be, that's what I can do, right? Old first dot next dot take. This will be a little bit nicer. And then we say self dot first equals sum first node dot clone, and then we kind of have to do this. So let's go here. So when are you doing a lock-free doubly linked list? I mean, I did one kind of with ref sale, I guess. I don't know. I guess it still kind of has like locks and stuff, right? I don't know. No, it doesn't have locks because it doesn't have the mutex. The RC ref cell was easier. I did this with an RC ref cell, I don't know, 6 months ago. And when I was worse at Rust than I am now. And it was definitely easier. I just wanted to go through the pain of using our mutex, I guess. If let sum first node equals old first dot next dot take, self dot first equals sum first node dot clone. This is correct. And then we actually need to get a lock. Now we have to get a lock on this node in order to update the prev. It's so terrible. It's so bad, guys. Oh my god. Okay, so then we're going to do a node.lock. Okay, so I guess we're just gonna start doing this. We're just gonna shadow because I'm tired of this. And we're just gonna do an unwrap. Okay, this is looking so good. And then we're just going to say something like dref first node dot prev equal, not first node dot, yeah, first node dot prev equals none. I think this is right. We might not need that little dref. Let's just try deleting it and see what happens. Oh wow, this is a lot. This is a lot. Okay. Not what I meant to do. Yeah, well, I know I found unit. I realized this. Let's just... I'm just going to return a 5. No, I'm just kidding. What is it? Is it to do? Yeah, we'll just... If we just add a little to do macro here, we're fine. If I remember right. Okay. And then it's just going to give me things that actually matter. Yeah, I forgot parens. I was wondering why something didn't look right. Where was that? Up here. Yeah, you're right. It should return an option. You're absolutely right. So then we can just replace the to do with none, and we don't have to think about all that. Let's see. Yep. Let mute first node. I forgot about the whole mutability thing. And this looks fine. Okay, so actually this code was mostly correct. This code was mostly correct. Okay. It's dirty as shit, but it's mostly correct. Self.len minus equals 1. Okay, so if let sum first node old first dot next dot take. If that's none, then we don't really have to think about it. We don't have to do anything special. Oh, actually, this could be our else for if this is the tail. That could be nice. So if there's no next, assuming we've done everything else correctly, then that means our self.tail should also, we can just do a self.tail.take, and we should just be fine with that. I keep calling it tail. It's last. Okay. So if there's no next node, that means that this is the only thing that exists in this whole thing. And we don't need the new first line anymore, so that's nice. Old first is there. Let's just give ourselves some vertical white space so this is a little bit more readable. And then what do we need to do next? So we've updated the existing node. We set self.first to that. We've taken off self.last if this is the last node. I think the only thing left to do, I believe, is return our value. So we shall see if that's true. So then we're just going to say old first dot value. Obviously, this needs to be a sum. And there's probably some sort of dereferencing that I have to do for this to actually work. I think. What do you mean you expected? What do you mean you expected unit? Oh, because I have it like this. Which is also why it typically, instead of doing an early return, I just deal with having a little bit of extra syntax and lines. Yeah. Yep. Cannot move out of dereference of mutex guard. Yeah. Okay. So can I do this, or is there something special I have to do? I think there's something special I have to do. So let's look at that. I'm guessing in the mutex docs. Consumes the mutex, returning the underlying data. Okay. Not surprised. This will, yeah. If another user of this mutex panicked while holding the mutex, then this will return. Okay, cool. So yeah, we're just going to go with a bunch of panics at this point. So let's see. We have that unwrap there, but this, old first is not the mutex though, is it? It's the mutex guard. It's the mutex guard. So maybe I need to look actually at the mutex guard docs instead to see what I'm supposed to do with this. Mutex guard. The lock will be unlocked via its dref and dref mute implementations. So how do I move it? How do I actually take all of the thing. I guess I need a deref, but the deref is and t. Is there anything that gives me a t out of this? I don't know. Doesn't seem like it. So this kind of makes me think I'm doing something wrong here. Like I have this lock, just deref and t, I know, right? I don't think that's going to work. Let's just see what I have on this first. Old first dot. I mean, this says old first dot value, but I know that's not actually true. I know that's not actually going to work because that's where it just was, right? Let's see. This is the part that I don't understand. So we moved it. I get that part. And I guess I can't just... What if I do a deref on old first? Let old first equals old first. What is this? That gives me an OT, which is what I would want. Does this work? No, because I still can't move out of the dereference of mutex guard. Because I'm still in a lock. So maybe what I want is to do all of this other stuff first, release the lock, and then go from there. So it's possible I'd rather do a map kind of like I had up here instead of an unwrap. I think that might be what I actually want. So if we say first.lock.map, love to treat that as a value instead of a method. And then we have an n, which isn't actually an n. It's a mutex guard. Okay. I think this is actually what I want. Because once this is done, then it's like over, you know, like this mutex guard should be done. The lock should be out of scope. We should be done with all of this. We'll see if this works. So what did this end up being called? Old first? Oh my God. Emacs, don't do this to me, please. Stop making everything highlighted where I can't even read one effing thing. Okay, so let's just do this. And see what happens. We're just doing an unwrap so we don't have to deal with it. And then, okay, so it's happy until we get to here now, which is expected. But I should be able to then just use first itself. And now I can use the actual arc method that I wanted to use to begin with, which is what? Into inner, I guess. Or I could do two owned. We could do an into inner, I guess. What just happened? Why did you put it after that? Maybe it's this? No? You hate this? All right. Cannot move out of an arc. So this is still bad, is what you're saying. Move occurs because value has type, mutex doubly linked list node 2, which does not implement the common trade. Okay, value move due to this method call. Yeah, I get that. Does lock move as well? No, lock just takes a ref. We're already out of that. Cannot borrow old first as mutable, as it is not declared as mutable. Well, that one's easy to fix. Just me being silly. Is that really what that whole problem was? Okay. And then we have this. Now I do kind of wonder, I don't think this should matter, but let's just do a first dot clone just to see if it fixes everything. Okay. I didn't think it would because it's a moving error. It's not, and because it's an arc. Value moved due to this method call. Can I take it? So I already took it. So like I already have what's inside of the option, but let's see. I think I'm probably just using the wrong arc method. I think that's the real thing. Either the wrong arc method or the wrong mutex method. I guess that's probably part of it. Oh, right. Into inner is the mutex method. I want whatever's on the arc. I want the arc to go away. I want the arc to go away. Oh, mim function dot take. I don't know. There's got to be the correct way. To get this back into your own little thing. I just don't know what that is yet. Okay. New cyclic, sure. Methods, assume init, downcast. What's downcast? To a concrete type. Returns a result, arc TA. What does this actually look like? Value.downcast string. If let okay string equals value.downcast string.len. Is it downcast? I don't actually know. What does n2 inner do? Okay, returns the inner value if the arc has exactly one strong reference. Okay. Otherwise, none is returned and the arc is dropped. Okay, this actually will work. I think this is what I actually want. Okay, so let's try first dot into inner, right? And maybe we want to, instead of using the implicit method, because it's like, where is this coming from? See, it says it's from mutex. So we're going to call it like this. We're going to say arc into inner. Hey, for Weeru. How's it going? Okay, so we're going to start with arc into inner first. Okay. And this should be an option. Let's get rid of this for a second. And let's just mess with this. So this should now be our mutex. Which is fine. And if we call m.into inner, m.into inner returns what? This returns a result. And I think what I'm going to do is probably just eat this result and make it into an okay. And let's see if I can remember how that works. Result. It's literally just okay. Yeah. Oh yeah, this is definitely Emacs. Of course it is. Okay, so now we have that. We have an okay. And that becomes that. Oh yeah, what does Rust call flat map again on options? I always forget. I don't think it's called flat map. It's called and. Is it called and? No, it's not called and. I always forget. Flat map. Oh, it's literally there. And then. And then. Okay. There we go. And then. Okay, so then we have m.into inner.ok, which is good. And then we should be able to map that. And this should be our actual node. And we just say in.value. Okay. And then if we do a little comma cf, we should have this formatted for us. Let's write it. I missed a, no, that actually is fine. And let's see where we're at. Let's go. Okay, that was painful as anything, but there you go. If you are whiteboarding a doubly linked list, I can very much say do not use ArcMutex. Okay, don't do it. Don't do it. You can look at my ref cell implementation. I'm not going to look at it myself right now because I don't want it to spoil this. But my RC ref cell implementation is not that bad. It's like almost whiteboardable. This is like if I didn't have an LSP, I would be going crazy right now. I mean, I'm already kind of going crazy. Let's be real. Okay. So so what we should see then is down here, we should have assert eq l.pop front sum 5. And then not what I meant to do, but we can do this. And we'll just see if this works. Beautiful. Have you thought of, instead of making your own your list own the data, it just owns indexes to a list that lives outside of it, so you can have two references to the same item without the trouble of having to do RC ref sale 2? It just owns indexes to a list that lives outside of it. Now, if you mean like indexes like the way that an array or a slice has indexes, then like that doesn't work because a linked list isn't an indexed data structure. So if you're going to have indexes, then you're kind of defeating the whole point of a linked list. So yeah. I mean, that sounds cool, but it's like different, right? Okay, and then let's just make sure that assert eq l.pop front on an empty list is none. We could have just done assert l.pop front is none, but you know, sure, we're just being crazy right now. Okay, looks good. So we have push front and we have pop front. They're both working just fine. We handled our tail case, like if this was our only element that we just popped off. So that's good. Now it's really just a matter of doing this for the back. So let's see how fast we can write this code. Oh no, arg's out of range. Come on, Emacs. Come on. Are you serious right now? Did we get back to it? Are we happy again? Okay. Oh, I recovered from an arg's out of range error. I was in the zone. I was just writing code, and then Emacs started effing with me. That's so not cool. Probably don't actually need that. Let me think. Okay, we'll just do them. We'll do that. It's fine. Next equals some link, and that should be the last of that. Dot unwrap. Okay. This looks fine. Otherwise, let link equals arc new mutex new in self dot last. Okay, wait. I forgot what I'm actually doing here. Oh yeah, this just means it's the only thing. So it's actually the logic is exactly the same. Really? Arg's out of range again? Really? Come on. Come on. Why are you being such a piece of shit right now? Come on. You can do this. Push back. Most likely correct. Let's see. Linked lists in Tree and Rust adds a performance overhead that doesn't exist in other languages by default. One way of implementing it would be to bookkeep the indexes, and instead of popping from the array, you empty it. Yeah, right. So, I mean, it's just like, but then it's like not even, it's like not even a linked list anymore. Right. But I get what you're saying. I think. All right. Let's write out pop back, and then we'll test these. Each item on the list still points to the next index. Yeah, but a linked list isn't. A linked list isn't about the interface. A linked list is about the memory layout, right? Is that you do not have to have a contiguous data structure underneath. I'm sorry, contiguous memory allocation underneath. Did I call it first up here because I was just like writing really fast? No, I called it last. Look at me. Oh my god. I'm so fucking great at this. I'm so good at this. Unbelievable. Okay, we're gonna do a last dot lock dot map mute old last, and this is where our code gets just so much better. Okay, let's see if this makes any sense. If let sum last node equals old last dot prev dot take. Okay. Let's see how this worked. Let's just finish writing this little thing. Else self dot first dot take, right? Because that means this is the only node in the list and we're popping it off the back, which is fine. And we do a little unwrap. Self.len. We're going to figure it out. We're going to figure out if it makes any sense later. In just a second. After I finish writing this code. Because otherwise I got distracted and then I won't finish the code. Looks fine. Else none. Okay. It compiles, but that doesn't mean our logic's correct. Let's just double check our logic real quick. So last dot lock, right. So we start with the existing last, right, which is this last. We end up calling it old last down here, which is fine. The old last, we check to see if there's a previous. If there is a previous, then we're going to change the trees last to the prev. And then we get a mutable reference to the last node. And we set the next to none. Yes, that is all correct. Okay, we're good. We're good. My inversing logic actually worked while I was typing. Cool. Enos1RL. Thanks for the follow. I appreciate it. So yeah, let's do a little. We'll do another pushback. Let's just do a 10. And we want to insert eq that l.len is 1. And we want to assert eq l.pop front is, I meant pop back, sum 10. And then we're going to assert eq that l.len is 0. Okay. Love it. Let's see if we got anything wrong. Okay. So for a very basic case, obviously we're only dealing with one element. Hey, I was right. I know you guys doubted me a little bit. I said, this logic is really painful, right? Push front and pop front were very painful for me. But once you got that figured out, once we figured out how to work with these arcs and these mutexes through pain and grit, we wrote pop front and pop back very quickly. It wasn't so bad. It wasn't so bad at all. So not too bad. Hey Maniac, thanks for the follow. So I'm not going to toot my own horn too much, but if I actually know what I'm writing, I can write code pretty quick. I know we're not used to that on this stream. All right. So let's just do a push front. Let's do a push front 5. We'll do a push back 10. We will do a push front 3. And then we'll do another push back 7. Okay. So let's just make this. I can't type after I just saw all that. So this should be 5, 10. There should be 3, 5, 10. And there should be 3, 5, 10, 7. Okay. And then let's see if all of these come through the way that we would expect them to. So let's just go ahead and pop front, sum 5. I think what I want to do is test this with pop front and pop back, and then maybe we can be pretty sure. We can be I already messed this up. That should be 5. That should be 10. This is why I wrote it out. This should be 7. Okay. And at the end of it, rl.len should be 0. And let's see how we did. Looking good. Okay. So let's just construct this exact same thing, but we'll use pop back. And this hopefully makes sure that our bookkeeping was all correct. Now, the only thing that we're not really testing that well at this point, I mean, we are testing that we're actually dropping all of our multiple references correctly, right? The arc into inner is working. Our mutex into inner and deref is working. All that stuff's working the way that we want it to, right? What we're not actually testing is that the next is like always correct, because we're not even actually calling next on any of these things. So in order to do that, we'd probably want to implement like the iterator trait, which I don't have time for today, but that would be the way that I would do it. Let's say front, back. So many asserts on the screen. I know. You know, I just write one huge effing test function. Oh no, we got a failure. Oh, that's just because I'm dumb and I put these backwards. Yeah, so surprisingly, when you use pop back, it doesn't pop it off in the same order as pop front. First try. Beautiful. Okay. I got to do a quick message check. 1 second. All right, we're good. You did that on purpose just to make sure something would fail. Yeah, I was just see, look, it's really not that bad of a test. Not that bad, okay? I'm pretty happy with this. I'm not saying it's beautiful code and I'm like, I'd want to show this to my mother. Just kidding. I wouldn't show code to my mother. I don't want to confuse her any more than she already is confused. But we got there. I mean, I didn't think I was going to finish, but I wrote a doubly linked list in under 2 hours live on Twitch. I'm pretty happy with that. We're asserting, all right. Lots of asserting. Okay, I did want to write a pinned. I don't remember what what was the type signature that I ended up with last time on my singly linked list for append. I think what I ended up doing. Oh, right. I just did immutable self. Okay, let's try doing this and see if we can finish it. So we take immute self and we take a list, which is just a self, and we return nothing because it's just a mutable method. And hopefully this will be like how simple this is. Of course, we are going to have to do some annoying things with like the locks and all of that, but we'll get there. We'll get there. Okay. So what actually has to happen here? I guess a couple things. First of all, we're going to say if let sum last equals self.last.take. And that's because we're just going to set self.last to none because we're going to change it anyway. We're about to change it anyway. Okay? So now we have the arc of last, and it's going to look pretty similar to the above to start with, where we're going to do a little map, and we're going to have our node, and then we're going to say something like, let me think. This is our last. We just got our mutex guard. We just mapped it. We need this in to be mutable. Mute, and this is actually going to be old last, so we'll just call it old last. And we're going to say old last dot next equals equals L dot first dot clone. Okay. That looks good. So our old last next becomes L dot first dot clone. Now whether or not, so this is just if there's already a last here. If there's not a last, then we also know there's not a first, right? And so if there's not a first, then that means that we have to set our self.first to L.first.clone. Otherwise, we're screwed. Okay. So we've set our old last next to the first of that list, right? And we've set our first to the first of that list if there were basically no elements in our list to begin with. And then we have to do two things. We have to make sure that we actually do this. That's important. We update our length of our self. And then there's one more thing. I'm getting there. Setting our last. Self.last has to equal L.last.clone. And since we're consuming L, all those other references are just going to go away. This should mostly work. This is supposed to be an unwrap. And there we go. Append in 5 minutes or less. Okay, so this looks pretty good. Let's just create a new list and append it to one of these before we're done. Still under 2 hours. You're right, Purplish. Let's just push a bunch of things to here. If you do it quickly, right? I mean, 2 hours from when I started the stream is where we're at right now. And I did read the article, I did read the article. We did that. All right. Let L2 equals doubly linked list Damn it, purplish. Use size new. And this is what we're actually going to do. Is we're going to say L.push front 3 L.push back 7. Okay. And this looks good. And then we're just going to say L.append L2. Okay. And after appending L2, what we should have is 5, 10, 3, 7. All right. So now all we have to do is say assert eq L.pop front sum 5. Ten, 3, 7. All right, let's see if we did it. Oh, I did want to check one more thing. I want to make sure that our length is actually 4. Let's see if I actually did this right. Did I actually do the ordering right? That'd be really funny if I fucked up append. All right. Left 3, sum 5. Oh, come on. Oh my God, I never changed this. It's hilarious. I never changed this. This is why you shouldn't write tests, guys. It's only going to make your life harder. First try on that append. All right. This stream was yet again a roller coaster, but I'm proud of myself and I'm really happy with where it ended up. Is this code beautiful? No, it's not beautiful. Working with arcmutexes, it really is. Like, I haven't done a lot with it, but like people say like, wow, so much pain, right? Like, just the amount of little things that you have to add is really annoying. If I was like writing this for real, what I would probably do is just create a little function that I could just pass one of these closures to, you know, and it would do all of this for me. And then I wouldn't have to worry about it. That's probably what I would do, so that this wouldn't be like littered through the code base of having these long lock map chains, etc. You can't get rid of all of them. Like here, it would be a lot trickier because I need a reference to self as well. And then you have to be like, okay, I guess I'm going to move it and then move it back. Like there would be annoyances, but it's probably what I would do, at least for like the basic, like I have this thing in an arc mutex and all I want to do is mutate the inner thing, you know? That's all. Well, I'm pretty happy with this. I will copy this code, put it in the article, publish the article later today. So if you do want to get the newsletter, all that kind of stuff, you can follow my Substack here. If you want dumb takes, you can go here. And if you want VODs and all that kind of stuff, it's here. And if you want to hang out with a bunch of nerdy people, then join our Discord. See you, YouTube. Next time, we're going to write a FIFO queue.